If sine theta is equal to 3/5, find the value of tan theta. So the question is sine theta is equal to 3/5. So in this question, we're going to use some simple techniques, which is called the SOHCAHTOA. SOHCAHTOA here means sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and then tan is opposite over adjacent. So from here you draw a right angle triangle, something like this. The 90 degrees over here. So let's label it A, B, and then C. So from here, the hypotenuse is the longest bar. At the same time, the bar facing the 90 degrees. So this becomes our hypotenuse. And then the opposite is this side. Adjacent becomes this side. So from here, when we look at the SOHCAHTOA, we can see that sine is over opposite over hypotenuse, which means opposite is the 3 and then hypotenuse is the 5. So you get 3/5. And then what is left over here? This very side. So we're going to find this side. And then by finding this side, we use the Pythagoras theorem, which states that the hypotenuse squared is equal to the sum of the opposite squared and then the adjacent squared. So we're going to get something like BC squared is equal to any of this, AB squared plus AC squared. And then from here, the hypotenuse, which is the BC, is 5. So we're going to get 5 squared is equal to AB. We have AB to be 3, so 3 squared plus, we don't know AC. This is the side that we are looking for. So we maintain this. We're going to get AB squared, AC squared, and then 5 exponent 2, we're going to get 25 is equal to 3 exponent 2, 9 plus AC squared. And then we make AC squared the subject. So we get 25 minus 9, which is equal to AC squared. And then 25 minus 9 is going to get 16. 16 is equal to AC all squared. So we take the square root of both sides. We're going to get root 16 is equal to AC. And then root 16 is 4. So AC is equal to 4. Now we've gotten a value for the adjacent, which is 4. And then in the question we are asked to find tan theta. And then tan is opposite over adjacent. So tan is equal to, tan theta is equal to opposite over adjacent, which means the opposite is 3 over here, and then the adjacent is 4. So this becomes our final answer. Find without using tables the values of sine theta and cos theta if tan theta is equal to 3/4. Again, we're going to use the same approach, which is the SOHCAHTOA. So we draw the right angle triangle. Then again, we label it ABC. So from here, tan is opposite over adjacent. And our adjacent is this, opposite is this. Meaning opposite is this one, and then adjacent becomes 4. So we're going to get 3, 4. So we find this side by using the Pythagoras theorem. And the Pythagoras state that this square is equal to the sum of this square and then this square. So we're going to get BC squared is equal to AB squared plus AC squared. And then BC we don't know, so let's maintain it. So BC squared is equal to AB we know AB, that is 3. So we're going to be 3 squared plus 4 squared. So yes, BC squared is equal to 9 plus 16. And then from here we're going to get BC squared is equal to 25. So when we take the square root over here, we're going to get BC is equal to 5. So this side becomes 5. And then we have to find sin theta. So sin theta is equal to, and then from here sine is opposite over hypotenuse, which is opposite hypotenuse. So we're going to get 3 over 5. That is for sine. And then cos theta is equal to adjacent over hypotenuse, which is 4 over 5. And that's all for cos and sine.